Hi, everyone. We will start the webinar in a few minutes. We'll wait for a few more attendees to join in. Please bear with us for a couple minutes. Thank you. All right, I still see people joining in, so maybe we'll give 1 or 2 more minutes. Hello, everyone who has joined. We are just waiting for a few more folks to join in. Please bear with us for a minute or two. All right, I guess we can start. So, hello, everyone. Good morning, good afternoon, and good evening to you all. My name is Mahesh, and I work here at Express Analytics. I lead the strategic consulting practice here. Thank you so much for joining us today for the webinar. Our topic today is Don't Wrestle with the Data, uh, the what, why, and how of data wrangling. About the webinar, we are currently having a 3-part webinar series about data wrangling. Our first session happened on May 6th, where we talked about the data sampling and data explorations. And today's webinar is the second in the series. And today we will talk about data cleansing and organizing. Now, before we kick off the webinar, a quick introduction of Express Analytics. We are a data analytics company delivering cloud-based analytics solutions, especially serving the retail marketing industry. We are a global company headquartered in the USA with delivery and sales teams in India, Japan, UK, as well as Malaysia. And we have been serving with many Fortune 500 companies for the past 20 years or a little over that. A lot of technology partners that we work with and a lot of clients we work with. So that's a quick introduction about Express Analytics. And now I will get to a little housekeeping as a moderator. Just a couple of announcements to make. While the webinar is on, you will be asked to answer a few opinion polls. It will come as questions on the screen, and you should be able to answer. All your inputs are welcome and very important to us. And second, during the webinar, all the attendees will be put on mute, but please feel free to key in all your questions in the chat box on the GoToWebinar panel, and we will answer them at the end of the session if we have enough time on our hand. Now, today's speakers are Samir Varudkar and Prateek Bhurke. Samir is our product engineering head, and Prateek is our data engineer, and we will shortly hear from them. So let's begin with the summary of our first webinar that happened on May 6th. That'll just set up the stage for this second one that we have happening today. So over to you, Samir, do the recap of our first webinar.
Sure. Hello, everyone. As Mahesh had said, my name is Samir Warudkar. I am the engineering head for Express Analytics, and today I'd like to just quickly recap what we covered in our May 6th webinar before we get into the content that we wanted to discuss today. So, in the previous webinar, we covered two major steps in the data wrangling process: data sampling and data exploration. Data sampling, as its name implies, is the sampling of your data set to create a smaller data set for faster analytics. There are four major ways that you can sample your data: random sampling, systematic sampling, cluster sampling, and finally segmented sampling. Random sampling, as its name implies, is picking data entries at random. The systematic sampling is where you take a fixed pattern and use that to determine which entries you will select for your sub data set. Clustering allows you to group your data into sectors of similar data entries and analyze them individually. And segmentation is taking all of your data, splitting it into equal parts, and then analyzing each individual segment on its own. And finally, we have complex sampling, which is taking two or more of these methods and using them as a composite. We also covered the five major types of sampling errors that can occur and how to avoid them. In terms of data exploration, we discussed what data exploration was as the primary examination of your data and how you can use data visualization software to spot trends and outliers in your data that could stand to affect your analytics, and how to identify the junk data entries that need to be corrected or eliminated during the data cleansing process. Speaking of the data cleansing process, that will be the topic covered in today's presentation.
All right, thank you, Samir. And we will get to the first opinion poll of today's webinar. So I'm just going to put a question in front of everyone's screens. I will launch it now. Please take time and answer this question. We just want to know if any one of you has attended our last webinar that happened on May 6th. We talked about data sampling and data exploration. So please take time to answer. We will give a few more seconds for everyone to answer. Okay, I still see that people are keying in their answers, so we'll wait a few more seconds. All right, thank you. So I'm going to close this poll and then we will move ahead with the rest of the webinar. So with that poll done, I'm going to hand the mic to Pratik to talk about data cleaning. Over to you, Pratik.
Yes, thank you, Mahesh. So, data cleaning is essentially the process of removing inconsistencies from data and refining it until it is in a clean, complete, and a consistent state, right? So, when we talk about completing it, the first step of data cleaning is you fill in missing values wherever possible. So if we do not have a value, but if we are able to obtain it through some other method, then we have to fill in this missing values. If not, we can fill it in with an average or a mean value. All right. Okay. So that is filling in missing values. Then completing it refers to making sure that all errors are removed. So any incorrect values which may exist in your data set, we have to make sure we remove these, and that is cleaning. Consistent means we make sure that all of our data values have the same standard format. Okay. And so ultimately, standardizing formats makes sure that our data can be passed in a consistent manner to our algorithm. or to our further cleaning procedures, right? So this is the three stages of data cleaning. We will look at all of these further in an example. But before that, let us now move on to the next part, which is telling us how does data cleaning actually help, right? So the first and foremost, unclean data is very frustrating to work with. There are a lot of errors, and usually the person working with unclean data usually has to pay a very high amount of attention. And if that attention lapses for even a short amount of time, you can propagate errors, and these errors can only get magnified and propagated through the rest of the data cleaning and modeling process, right? So unclean data is not only frustrating to work with, but it can lead to errors, which will ultimately lead to a decline in the satisfaction of your clients. And that is something every organization definitely wants to avoid. Next, if your data is clean, like I mentioned, unclean data requires human attention, right? So that should imply that clean data requires less attention. Also, if your data is clean and standardized, that means it can now be passed to an algorithm, and now a lot of your tasks can be automated. If you've ever seen an assembly line in a factory, you notice all the items being manufactured pass in a very streamlined and a highly ordered manner, which is why the machines are able to work with them. Now, imagine if they were all helter skelter on the assembly line, a lot of the machines would cause error and cause objects to topple. Therefore, clean and streamlined and standardized data enables a lot of automation and improves everyone's efficiency. All right. Third point, clean data always trumps better, fancier algorithms. Basically, algorithms can only take you so far, right? Because ultimately, the raw material you're working with is of low quality. You're not going to get very useful insights out of your data, and there could also be a lot of errors in the final insights which you receive, right? So, to give you an example of everyday life, if you don't clean your vegetables before making your soup, no matter how fancy your recipe is going to be, ultimately your soup will taste of mud because you didn't clean your vegetables before you cook them, right? All right. So that was why is data cleaning so important? Now what we're going to do is actually look at an example of data cleaning, which is going to be done in Google Sheets. All right. Now, one very important disclaimer, this is only an example. Okay. In reality, what we actually use is a lot of scripts and a lot of queries and a lot of other data management tools to clean our data. But for the purpose of visualization, we are using Google Sheets. All right. In reality, we usually have databases or data warehouses with thousands upon thousands of records. Here we have a small sample data set which we found online, and we are now going to attempt to clean. Once again, remember, we usually don't use Google Sheets. We use algorithms. Anyway, now let us switch over to Google Sheets. All right. So right here, we have this data where this is from the USA, by the way, where gifted and talented children have written these exams called the ALSAT and the NNAT. The parents of these children are now entering their verbal scores and percentiles, and they are possibly giving in trying to apply to or are giving feedback about which schools for the gifted and talented they would prefer, and which ones they have actually been allotted to, right? So let us just take a look at this data first and just take a look. So we have the timestamp when people have responded. We have the grade that the child is about to enter, district, birth month, their scores and percentiles, their school preferences, and whether or not they will enroll, right? So before we do anything else, we want to make a copy of this, all right? Now, this is because in case something goes wrong, we still have our original data, which is going to be untouched and in its pure raw form, okay? So at least if something goes horribly, horribly wrong, we can start over, right? All right. Anyway, now I have a copy of this data, and I am going to rename this sheet to clean data. Okay. Now, let us look at the values we have on our screen right here. All right. So these five seem to be numeric values, right? So let's just take a first thing to view all the values in Google Sheets. A helpful little tool right here is to filter. All right. So what we're going to do is just start up a filter here and make sure we can see the first row at all times. Okay, great. Let us look at the values in all sat verbal. All right. So here we have a lot of numeric values, but here down here we have some blanks, we have some asterisks. Here some parents have entered the scores as a fraction out of 30. So they have entered it as marks obtained out of maximum marks. And someone I just said fill out later. All right. So first thing we need to correct is to standardize the format. Everyone else has written it as just the score they've received. We need to make sure these values are in the same format. What we're going to do for that is we're going to select this column. We're going to look for the string which we do not want and replace it with a blank, which is basically nothing. And then we just hit replace all. Now, if we look at this column, we notice that those entries are now gone. And now it's purely numeric, right? Let's do the same over here. As you can see here as well, we have some entries which say out of 48, right? We want to get rid of the out of 48. So we're going to do that over here. And done. Right, let's take a look. Okay, looks good. Now, the next thing we want to deal with is there are more anomalous values right here. Yeah? See these? We want to now only look at these three entries or these three values. Okay, this person has just not entered a mark over here, right? So basically we can assume these values to be null. So let's do that. Similarly, I can also see that this record right here says approximately 70, right? Let us change this to 70. Now, in the earlier case, I simply deleted the values because there was no way for us to approximate or assign a value to it. In this case, the person tells us that there is approximately 70, which is why we are going to simply assign it the value of 70. Okay. Now, let us continue looking at all of these values. Okay, we remember that the score was out of 30. Here we have some scores up to 35, and then we have some scores which go up to 80s and so on and so forth. So we only want to look at these anomalous scores. Right. So here, first of all, we notice that this number and this number are different, right? So perhaps for this person, the exam had a higher rating, or it may just have been that this person got a 32, right? Because maybe their exam was slightly different depending on what subject or whatever. Let us leave this value as it is. Let us also leave this value as it is because this value seems to be okay, right? So let us ignore this 32 value right here. Let us look at 35. 35 also seems to be anomalous, but perhaps their exam was different depending on the subject or what fields they was testing. Let us also ignore this value and let it be. Let us look at these values right here. Hmm? If you notice, these values here are the same as these values in the percentile. Basically, this person has entered the percentile in place of the marks. So these values are incorrect. So we have to remove these. Why do we remove them? Because we have no other way of approximating or guessing what the original value could have been, right? So we're going to get rid of all of these values. Right. Let us now look at what our values look like. Okay, this now looks okay. So let us select all these values again. Yeah. Okay, let us look at all sat non-verbal. Is it all numeric? It is all numeric. Excellent. Let's leave it as it is. Let's look at nnat non-verbal. Looks good. Maximum mark was 48, and here we don't have any values over 48. This looks fine. Percentile here, all looks fine. Okay. Overall score looks good. All right. Birth month. We have 12 months and 12 entries, no other anomalies. Excellent. Now let us look at the school preference. Here we are going to have a lot of different values, right? Because everyone's perfect preferences could very well be unique. So what we can say is that this is more of a label attribute or a label field or a text field, and this does not give us information which we can use in our actual modeling or in our actual analysis. So this is a column we perhaps do not require, and therefore we're going to mark it as gray. It will be in our database. It gives us some form of information, but it is not useful for our final analysis. Okay, so let's just leave it here and mark it in gray as okay. We're not going to really need it right now. All right, let us look at school assigned. Okay, once again, same story, many different options, and perhaps not even useful as a categorical variable. So let's mark it gray. Will you enroll there? Yes, no, maybe, yes, no, maybe, yes, no, maybe. Let's look at all the values we have here. We have one yes, which is just slightly differently spelled. Let us change that to be just a simple yes. All right. Now, naturally, of course, you would have to pick that up with some sort of a command in your algorithm or your script, because usually you will have tens of thousands of such records, and you cannot obviously clean each and every one of them. Right now, I'm just showing it to you as an example, right? Okay. So now that is all clean. Let us look at district, right? We have values for most of it, but we have a lot of blanks over here. Now, since these are all ordered by the timestamp, we can see that all our blanks appear at the beginning. That means some action was taken, which is why parents have now started adding the district. It could be possible that the parents who entered who entered these responses earlier did not know what the district was, and so they left it blank. Which means this information was later made available and was then entered by the parents when they were filling out the responses, right? What do we see here is that sometimes no information is also information. All right. Finally, we have to talk about standardizing the formats. We've standardized the format here and made it all a numeric value. But here we see that this is a numeric value because it's a 1, but this is a k and it is treated as a text value. Google Sheets will treat numerical values and display them on the right side of the cell, and text is displayed on the left side of the cell. Now, although this is a grade 1 and a grade 2, this is not a numerical value which will have any mathematical meaning behind it. So essentially, this is a segment, right? So we can treat it as text. And so we are now going to convert this to simple text. And like just like that, we now have all of these on one side. And now this is nothing more than a segmenting variable. All right. Now let's take a look at what other values will not be useful for our analysis. Obviously, timestamp is not going to be useful for our analysis, but still good to have in our database. Okay. Let's see. Overall score, it is mainly in the 90s, right? We do have one outlier, which we can consider whether we want to remove this outlier or not. Okay. But generally, if all of your variables are on one side, or if this, since we see the segment of 100 to 90 percentile, the top decile, so to speak, is largely overrepresented here, and this 76 is an anomaly. So this doesn't tell us too much, and we can perhaps ignore this column from our final analysis. Now, naturally, it depends on case to case. This is just an example. So in this example, we are choosing to ignore this. Let us look at NNAT nonverbal. Now, all the responses are in that one bracket, but they are distributed throughout that bracket, right? So in this column, perhaps we can leave this column as one of the variables which we will consider in our analysis. Let us look at NNAT non-verbal scores. Yeah, they seem to be rather evenly distributed. We are definitely going to keep this. And non-verbal percentile is also quite well distributed. We can definitely keep this in our analysis. Same with the ALSAT verbal score. Birth months, well, it could be important if we choose to look at only one segment and we need to sample our data using segmented strategy. Segmented sampling strategy, we can possibly segment by birth month. Let's keep that in there. We could also sample by entering grade. Now, naturally, we can assume that if we want to study grade wise, then perhaps it might help to segment or cluster these according to their grades, right? And study each segment separately. All right. Finally, we look at district. Now, this column has a lot of blanks in it. Okay. Now, generally speaking, if your algorithm can handle blanks or the lack of data, that is great. And then perhaps you can leave them in. But if blanks are absolutely detrimental to your algorithm, it is generally safe to remove up to 5% of your observations if you wish to delete the entire row because you have a blank. Okay. So if we go back to those particular values which were blanks here, let's just look at the blanks here, right? We have these 7 values where we do not have any of these scores, right? Perhaps we could consider removing them from our analysis entirely. Again, like I said, up to 5% is generally okay. Why do we say that? Coming back to our vegetables example, if you try to clean too much, at some point, if you overpeel the potatoes, you're getting rid of perfectly good potato, right? Similarly, here you're getting rid of perfectly good data, right? And that is information you preferably do not want to lose. So although you are losing some data to reduce the uncleanliness of the data, ultimately you don't want to be throwing out too much of your clean data. Okay, so in the end, what we have here is a data set which is now cleaned. All the format is standardized, and we have identified variables which are perhaps not so significant for our analysis. With that, this data sample is now ready to be ordered, organized, and then analyzed. How we're going to go about that, we're going to take a look at that very shortly. For now, I'm going to hand it back to Mahesh. So Mahesh, that was it from me on data cleaning. Please take it away.
Great, thank you, Pratik. That was really informative. So we're gonna do the next poll really quickly. So I'm gonna uh, put it on the screen. We just want to know, now that we just heard about data cleansing, we want to know what kind of confidence level you guys have with the data in your organizations that you handle right now, with varied degree of confidence as well as something that you're completely not aware of. So I'm gonna wait a few more seconds. Um, Please answer the poll. All right, maybe 5 to 10 more seconds and we will close this. All right. Thank you everyone who has answered. And with that, we will move on to the next topic, which is data organization. So over to you, Samir.
Thanks, Manish. So, right, after we have our data cleansed, the next important step is implementing a strong organization strategy to our clean data. So, fundamentally, the idea is that when you're working in a large organization, oftentimes you're going to have multiple teams who are working on data, and you're going to have multiple sources of your data. For example, you're going to have data that's coming from your brick and mortar stores, from your online sales. You might have customer data. You might have data on the products you're selling. You might have data on the vendors that you trust. And in addition, from yourself, your brick and mortar stores, your online store team, and even your vendors, all of these different sources of data are not necessarily going to have a unified standard format. So even after you've cleaned your data, you need to have a strong strategy for organizing and standardizing your data into a single consistent format across the board. The question is this, uh, why do we need organized data? Well, at its core, organized data allows easier access and makes the job of coding your analytics or building your data models significantly easier. At its core, you want to be able to have a algorithm that you've designed that can predictably produce an outcome or perform as expected, no matter what data you're intaking. So whether that's just a small sample or the full brunt of your data within a certain arena of your business processes. Essentially, your core goal is just to be able to say as an individual that your job is so much easier. And it's understandable as to why. As Pratik had said, oftentimes when you're working with your data, you can't do it manually. You have to have an automated process because you're working with a year, 5 years, 10 years, maybe even 20 years of data. And so it's just not feasible to try and do it and handle your data on a case-by-case basis. So what types of data organization strategies should we consider? Well, it depends on what your needs are. For example, if you are trying to do online transactional processing or OLTP, you might want to consider using third normal form, which is a standard of database design that lends itself really well to those types of applications. Similarly, if you're trying to do analytical applications, which is more within the scope of kind of what we at EA do, you might consider dimensional modeling, like a star schema, where you have a fact table and a series of dimension tables that are attached to that fact table via keys. So let's dive a little bit into that. So suppose we take the example of a used car lot. That used car lot has a large number of cars that they have from previous sellers coming and selling their cars to the organization. Well, if they want to track all of their cars, they're going to have a series of different fields within their data, which are all equally important. You'll want to know the year, make, and model of every car that's on your lot, as well as who sold it to you, and other information such as the date of birth from that person when they sold it to you, which might be in your database for previous vendors. The issue, though, is that keeping all this data in a single data frame like this is not necessarily always useful. For example, in real world applications, even if a previous owner has sold you a car, birthdays are not so unique that there won't be the situation where you can use date of birth as a key, because there will be multiple people who have the same birthday and will be selling cars to you. Similarly, the name of the owner may not be a particularly great choice in this case to narrow down the data that you're looking at, because unfortunately, people might have sold you multiple cars over the course of their lifetime, where each car that they sell you is used to bankroll the next car that they buy from you, and so on and so forth. So ideally, what you want to do is be able to take your data and create a fact table which has all of your sales, and then a series of dimension tables where each dimension handles a different aspect of the overall data that you're looking at. For example, you would take the table that we were looking at and split it into two different dimension tables. One which handles each of the individual cars on your lot, where you have the year, make, model, and the previous owner who had sold it to you, and then a owner's dimension table, which covers each owner as well as their date of birth and any other pertinent information that we might have in our database. By keeping these separate, you have the ability to handle each of your individual aspects of the data and be able to use them more easily when it comes to actual data modeling. So let's say that we have implemented an organization strategy. Well, what then? How does this play into the next step of the data wrangling process, which is, of course, going about modeling? Well, the answer is this. Once you have your data organized into a well-defined organization structure, you can much more easily plan out your modeling options. For example, with a data set that is organized into a star schema, you can essentially pose your questions and organize your thoughts into trying to find analysis based off of certain questions. Let's hop back to the example that we have of the gifted and talented students. We might want to look at whether there's a correlation between the age of the student and how well they did on the different exams like the OSA and the MNAT. Or we might want to see if there's a correlation or find out what is the distribution of birth date of persons to where they ranked in overall percentile. Well, by having organized data, you'll be able to easily draw the connection and see that of the many models that you might have options for to utilize for your analytics, whether that's linear regression, logistic regression, or any other model that you might have at your disposal, you'll be able to identify what is the correct choice for what you are looking for. Being able to make this process will make your future actions in the data wrangling process, such as data modeling and data testing, significantly easier.
Thank you, Samir. And just to add to that, Express Analytics being in the business of data analytics for over 20 years, we do have deep expertise in data organization, specifically in dimensional modeling. That's the day in and the day out thing that we do, dealing with the analytical systems. So with that, with that said, here comes your third question, where we want to know, not just like mostly into the dimensional modeling data organization strategy. We wanted to know where you lie and how confident you are into your own strategies, may it be for OLTP systems or analytical systems. So please take a little bit of time and answer this. I'll wait for 5 to 10 more seconds so that everybody gets a chance to answer. All right, I think we are going over time as well. So I'm going to close this poll. I think I have got the answers. With the third poll done, now I would ask Samir to quickly summarize today's discussion. Samir?
Yeah, so to review kind of what we covered today, data cleansing allows for us to turn our data from its raw form into a form that is easy to understand and can facilitate repeatable data analytics. Your cleansing can include things such as filling in empty fields that are vital, correcting inaccurate data points, standardizing the formats of the different fields that compose your data, as well as learning when you can and cannot remove data from consideration without harming your overall process. Similarly, data organization is a vital step in the data wrangling process. It allows us to easily implement data analytics options in the future, as well as determine which data analytics options are viable for our questions. It also allows for a good standard format for making the automation of your data analytics easier in the long term.
All right, great. Thank you, Samir and Pratik. I think that was a great discussion today, with even a few real life examples that you guys shared. So thank you for all your insights during this chat. And to all the participants, thank you so much again for joining us today. We have received a few questions in the question box, but I think we are already way over time. So in the interest of time, we're going to stop here. But I promise that we will answer your questions personally, one-on-one, through emails. And there are some contact details here on the screen. So if you have any questions about today's session, or data analytics or data wrangling in general, please write to us, to one of us on the screens. And so as I said earlier, we are going to have this webinar series with 3 webinars. Today was the second one, and we are going to have one more, the last one, on May 14th, where we are going to talk about the data modeling, as well as testing your models. So I invite all of you to register for this webinar on May 14th. Thank you so much for joining us today, and see you again on May 14th. Bye-bye.